Hey there, Dr. B here. It's time for worksheet 7.9. This is the HBrONClIF worksheet. HBrONClIF is the name of those elements which bond to themselves commonly. That means, there it is, hydrogen, bromine, oxygen, nitrogen, chlorine, iodine, and fluorine will form diatomic molecules. That means only when they're alone. H2O is still H2O. Don't think that H2O being on the list might become H2O2. It's only when it's alone. So, let's read this little blurb and we'll get started solving some problems. One of the most common sources of confusion in a first-year chemistry course concerns the diatomic molecules. These are the elements that prefer to bond to themselves in their pure elemental state. The diatomic elements include hydrogen, bromine, oxygen, nitrogen, chlorine, iodine, and fluorine. Hence the mnemonic HBrONClIF. They all exist naturally as H2, Br2, O2, N2, Cl2, I2, and F2. Bonding them together is a great way to get familiar with valence electrons and electron dot structures. For example, oxygen forms a double bond, nitrogen triple, all the other ones are single, but that's another story. Now, the two most common errors that students run into, and I've already alluded to them, but I'll do it again. Students sometimes forget to write these elements as diatomic molecules. The oxygen you are breathing does not have a molecular formula of O, it's O2. Students sometimes assume that if elements are part of a molecule, they still must be in pairs. Not true. Water is H2O, not H2O2. Chloroform is CHCl3, not CHCl2, or CH2Cl2, you might think as well. Okay. Example, correct the formulas for the following substances when necessary. For example, O should be O2 because it's on the list. I is fine. Carbon is okay, it's just carbon. Boron is not on the list. It's Br, see that? Bromine is, make it Br2. N is, make it N2. Copper is not. Aluminum is not. Fluorine is. Your turn. Oxygen. Fix it. O2. Fe, it's fine. In, it's fine. Ru, yeah, it's fine. I, should be I2. F, it's on the list. F2. Ar, it's fine. Fluorine, it's on the list. Hydrogen, it's on the list. H2. See how easy this is? So write formulas for the following elements or molecules. We'll be using words, and now you got to apply. Water, H2O, that's right. I assume you're trying these. Carbon dioxide, CO2, just like it says. Carbon tetrachloride, CCl4, just like it says. Fluorine, says F, but no, you want F2, it bonds to itself. So does nitrogen. Carbon monoxide, I guess I just need CO. Br2 is what you want there because it's on the list. HBrONClIF. Iodine is on the list, I2. Gallium's not on the list, so Ga is fine. Sodium iodate, not sure why that's there, but that's NaIO3. And here it asks, why is chlorine diatomic? Show a Lewis dot structure, showing how Cl2 is just perfect. I think that's a worthwhile exercise. And there it is. Notice that each of those chlorine atoms started with 7 electrons. In other words, that line means 2 electrons. Originally it had 7. Maybe that dot would be on the bottom. The other chlorine had 7. That dot would be out top. When they merge, they end up forming Cl2. They share those 2 electrons, meaning 2, 4, 6, 8 happy. 2, 4, 6, 8 happy. Life is good. Interestingly, you can also use the term genene if you want. Anything that ends with Gen, like oxygen, or INE like fluorine, will be diatomic. This is the HBrONClIF worksheet.